Lab 3 CDP. Objective: to understand how the Cisco discovery protocol functions and what it takes for Cisco devices to be discovered. Lab equipment. We will be using router 1 and router 4. To select router 1, click on the button router 1 at the top of the screen. On router 1, enter global configuration mode. On router 1, change the host name to R1. Select router 4 by clicking on the button router 4 at the top of the screen and change the host name to R4. Note: by default, all interfaces are shut down. Enable the serial 0 interface on R1. Now enable the serial 0 interface on R4. Enable the Ethernet 0 interface on R1. CDP allows devices to share basic configuration information. CDP will operate without any protocol-specific information configured. CDP is enabled by default on all interfaces. CDP is a data link protocol occurring on layer 2 of the OSI model. This is important to understand because CDP is not routable. It can only traverse to directly connected devices. On R1, type the command to give the status of all interfaces that are running CDP. The sample output below shows that both interfaces are up and sending CDP packets. Now that the router has interfaces that are broadcasting and receiving CDP updates, we can use CDP to find out about directly connected neighbors. On R1, type the command to provide information about directly connected neighbors. Below is some sample output. The first device on the list for R1 is R4 via the serial 0 link. R1 is receiving CDP updates from R4. The updates tell R1 to hold on to the information for a specific amount of time. At the time this command was pressed, there were 148 seconds left in the hold time for R1's update. If that time expires before receiving another update, R1's information will be removed from the table. R4 is a 1000 series router. This is shown in the platform column. The final column, port ID, is the port on the other device from which the updates are being sent. On R1, type the command to provide more detailed information about directly connected neighbors. Below is some sample output. This command shows devices one at a time. It is used to display network layer address information. At this point there are no configured IP, IPX or AppleTalk addresses, so this field is blank. The command also displays iOS version information. Notice that the devices are listed in order. If one wants to find information about a device further down the list, one would need to scroll down using the spacebar. On R1, type the command to provide information about the specific device R4. The below is sample output. This command gives the same information as the shown CDP neighbor detail command, but allows a single device to be specified. Also notice that this is one of the only case-sensitive commands that exist. On R1, type the command to see how often CDP updates are being sent and how long a recipient is to hold on to the update. The below is sample output. On R1, type the command to adjust the amount of seconds between CDP updates to 45. Besides the update interval, the hold time value may also be adjusted. This value tells the recipient of the update how long to hold on to the CDP information in the update. It is also a global parameter. On R1, type the command to adjust the hold time timer to 60 seconds. On R1, type the command to verify the changes made. The below is sample output. On R1, type the command to disable CDP for the entire router. On R1, type the command to turn CDP back on for the entire router. At times you may wish to disable CDP for a specific interface, for example a very low bandwidth interface or security reasons. On R1, disable CDP for only the specific interface Ethernet 0. On R1, type the command to verify that Ethernet 0 is no longer sending CDP updates. You can verify that the interface Ethernet 0 is not sending CDP updates because it does not show up as an entry in the output. Below is a sample output from the command.